Today I wanted to talk about photogrammetry. This is a technique for using software to process images from a digital camera to produce a 3D model. What I like about this technique is it's easy, inexpensive, and really effective. Just by using a smartphone, we can quickly build an inventory of detailed 3D geometry that can be used in a number of ways. It can be used as assets for digital art, whether it's still, moving images, or in a gaming environment, or they can be used in the context of digital fabrication, from 3D printing to CNC machining. This tutorial will cover a basic workflow for using software like Agisoft Metashape to process images we make simply from using a smartphone camera. Alright, so to get started, first I'm going to cover how to shoot. In selecting a camera, you just want to keep in mind that the higher the resolution and the sharper the lens, the better the results. But most smartphones these days have really high quality cameras. The main point is we're trying to take between 30 and maybe up to 100 photos of a single subject from as many angles and vantage points as possible. You want to find a subject that is both solid and has an opaque surface. What really causes issues is when you're dealing with anything that's transparent or translucent or has a reflective surface in particular. You also want to avoid anything with super delicate and complex details. Textures like vegetation or hair, anything that's extremely delicate is going to be difficult, if not impossible, to get good results from. The last thing about your subject is it needs to be perfectly still and cannot be moving at all during shooting. You want to make sure that the lighting is uniform. You want to avoid hot spots or any dramatic shadows. Ideally, if you're shooting outside, you want there to be some clouds in the sky and not really intense direct sunlight. Next, you really just want to make sure that each image is in focus. You don't have to do anything super fancy, but you do want to be very methodical. Basically, you want to start from one angle and move laterally in a circular arc around your subject. A good rule of thumb is to shoot, step, and after a full pass or a full rotation, change your angle and then shoot, step, and keep doing this until you've gotten a couple different angles in 360 degrees around your subject. You definitely want to take more images than you think you need. You can always delete them, and it's more difficult to combine multiple shoots since often your subject is either moved or lighting conditions are different. So you want to try to do this in one session. The next thing you want to avoid is any sort of zoom. This creates additional noise and lens distortion that creates problems with the software. Instead, bring the camera closer to the subject. You also want to make sure that each photo is either taken in landscape or portrait orientation, whichever is more comfortable for you. But what you don't want to do is alternate or switch back and forth between these two modes. This will produce errors and increase processing time. Lastly, the devil is in the details. So if there's a particular area of interest that you really want to capture, make sure to get more photos and angles of that feature. As far as the number of images, a good rule of thumb is you want to shoot at least 30 images from as many possible positions as you can. Shooting too few images can result in a low quality scan and lots of missing data. Shooting too many images can overload your computer's ability to process everything. Larger image sets require exponentially more powerful computing hardware. So now it's time to bring all our files into our computer. And first, we need to do a little bit of editing, not much. But the main thing is to make sure that we get rid of any bad images. So what is a bad image? Number one, anything that doesn't feature our subject. Delete it. Number two, anything that's out of focus. Number three, anything that's in a alternate orientation. So for example, if you shot landscape, but then you have a few portraits, delete those portraits. Any images that just have too many shadows, you accidentally put your finger in front of the lens, go ahead and delete those. If you have two images that look identical, only keep one. This will save a lot of time processing. Alright, so when we first open up Metashape, what we want to do is basically add our photos to what's called a chunk. To do that, you'll right click on it, go to add photos, and then I'm just going to select all of my photos. So we see in my case I have 95 cameras, which is a lot. Next, what we're going to do is we're going to go down to process and we're going to align the photos. And you want to be very careful about not overloading your computer. I would not recommend starting off with highest. Let's just do high for now. Just go with the default selections. We'll hit OK, and that's going to load for a bit. Okay, now that that's finished, what we're going to do is optimize our cameras. So we are going to go into our chunk. We're going to go to process. We're going to go optimize cameras. And it's okay to just have everything checked here, and we'll just hit OK, and that's going to process. And so what we're looking at here is what's called our sparse point cloud. So you see all these dots, and these are more or less a very rough sketch of our scan. And what we need to do now, before we go any deeper, is actually clean up this scan. So you can do this manually, but you can also use a tool up in Model under Gradual Selection. And there's actually 3 tools here that you'll want to select. And the first one is Reconstruction Uncertainty. If you select that, I typically recommend you to set this to 10. If this is way too much and it deletes too many points, you can, of course, increase that. So let's try 15. I'll hit OK. And that basically selects points that are maybe misaligned or not in the right position. And we're just going to go up and click delete. And that greatly reduced a lot of the noise in our model. Next, I'm going to go to Reprojection Error under Gradual Selection. And for this, we want to be around 0.5. So I can go ahead and type that in. And again, I'm going to delete these points. And you can see as I'm doing this, the number of points that are in the chunk are decreasing. So we're going to do this one more time, go to Gradual Selection, and this time we're going to select Projection Accuracy. And this we're also going to set as 10. I'm going to delete those, and that reduced our points down to around 250,000 points. Before I continue, what I'm going to do is actually manually delete some of these, and I'll show you how to do that. You can choose these selection tools at the top, like rectangular selection, and I'm just going to draw a box over what I want, and instead of hitting delete, I'm going to hit crop. That's going to delete everything except what I selected. And Usually if you want the entire scene, you can leave the majority of the scene, but just know that that's going to take a lot longer to process. Typically, I recommend for folks to actually delete everything except for the object that you want. The other thing that you want to keep in mind before we continue is this bounding box here. So when we process and build the dense cloud, it's only going to build what's inside this box. And if I want to move that around, I'll go here to resize region. And when I click that, these sort of points come up. I can bring these in. And so this can greatly reduce the amount of time you're processing this by shrinking this down. All right, so I'm happy with that. So next, also make sure to save often, because a lot of times when your computer's doing these heavy processes, it can crash. So make sure you save. So next, we're going to move on to process and build dense cloud. Just to save time, I'm going to click on medium. Ultra high might take literally days, and medium should only take a few minutes. All right, so now we've got a dense cloud, and you can sort of toggle that on and off here. You can see it's a little bit more refined. And so now what I'm going to do is go back into my chunk. We're going to cruise along to building the mesh. Here you can either select the sparse cloud, depth maps, or the dense cloud as the source to create this. We're going to select dense cloud. Arbitrary will create a sort of more three-dimensional scan. Height field will be a much faster scan, but it will only be the top surface of your model. So just to demonstrate, I'm going to do arbitrary. Quality, we're going to stick with high, and we'll hit OK. All right, so that finished. And if I go up here and I have my solid model, you can see that it's even more refined. And now what I can do is, one thing I'd like to show you is you can actually see where the images are aligned. This sort of simulates where in three-dimensional space I took each image, and what I'm going to do now, and you can sort of swap between wireframe, mesh, and a solid mesh to check out your model. And the very last thing I'm going to do is go back to process, and we're going to do build texture. And I'm just going to stick with the defaults here, hit OK. And this is actually going to map all of my images onto the model. And this will make it look realistic. And since that's done, we'll go to textured model. And I'm going to get rid of those, and voila, there you have it. 3D scan. And so you can zoom in pretty far and start to see some pretty interesting details. You can kind of tell that certain materials do better than others, like this sort of shiny plastic had a little bit of difficulty in rendering something accurate, but this sort of concrete had no problem, simply because it's very matte and textured, and you can get a lot of nice detail out of something like that. And there's a little sponge inside there. So that pretty much does it. You can, after you get this, you can sort of use these manual tools, these manual selection tools, to delete even more aspects of this. And if you want to incorporate this into other software packages, other workflows, you can go to File and Export, File, Export Model. You can choose all sorts of types of models. I usually export as an STL if I'm using this for digital fabrication. But if you're using this in Blender or 3ds Max or Maya, some sort of video editing software, you might want to try OBJ or 3ds. There's a lot to play with here, and that's pretty much it. Thanks for watching. If you'd like to learn more about this or have any questions, feel free to reach out to me and send me your models. Send me some images of some collages you've made, and I can't wait to see what you come up with. So talk soon.